Hello everyone, welcome back to my channel. In this video, we are going to discuss some of the most frequently asked interview questions on Kubernetes. So let's start. So first question is, what is Kubernetes? Each of the questions we will be discussing along with the examples. So first question is, what is Kubernetes? Kubernetes is an open source container orchestration platform used to automate the deployment, management, scaling and monitoring of containerized applications. In simple words, Kubernetes helps organizations manage multiple containers efficiently without handling everything manually. It ensures applications run smoothly, remain available, and can scale automatically when the traffic increases. So we'll understand this with an example. For example, imagine an online shopping application with different services like login, payment, product catalog, and notifications running in the same container. So instead of manually starting, stopping, and monitoring each container, Kubernetes automatically manages them. If the traffic suddenly increases during a sale, Kubernetes can create more containers to handle the load. If a container crashes, Kubernetes automatically restarts or replaces it. In simple words, Kubernetes acts like a smart manager that controls and maintains all the application containers in a cluster. The next question is, why do we need Kubernetes? So we need Kubernetes because managing containers manually becomes very difficult when the applications grow larger and need high availability, scalability and reliability. Kubernetes automates tasks such as deploying applications, scaling them based on traffic, restarting failed containers, balancing workload across servers and managing updates without downtime. This reduces the manual effort and helps the applications run smoothly. For example, imagine a food delivery application running multiple containers for login, payments, order tracking, and notifications. During the peak hours, thousands of users may access the app at the same time. Without Kubernetes, the team would have to manually add servers or restart the failed applications. But with Kubernetes, it will automatically handle these tasks by creating more containers when traffic increases and replacing the failed containers if any issue occurs. In simple words, Kubernetes is needed to efficiently manage large-scale containerized applications in a reliable and automated way. The third question is, what is a container? A container in Kubernetes is a lightweight package that contains an application along with everything it needs to run, such as code, libraries, dependencies, and configuration files. The main advantage is that the application will run the same way in development, testing, and production environments without the compatibility issues. So let us understand this with an example. Suppose a company has a Java web application. Instead of installing Java and all required software separately on every server, they can package the application inside a container, the entire application inside a container. Kubernetes then manages these containers automatically. It can start them, stop them, scale them, or restart them if they fail. A simple real-world example is a food delivery app where one container runs the payment service, another runs the login service, and another runs the notification service. Kubernetes manages all these containers efficiently. The next question is, what is a pod? A pod in Kubernetes is the smallest deployable unit in Kubernetes that runs one or more containers together. You can think of a pod as a wrapper or a small environment that holds the container and provides it with networking and storage. Containers inside the same pod can communicate with each other very easily because they share the same IP address and resources. For example, imagine an online shopping application. One pod may contain the main application container and another helper container for logging and monitoring. Both these containers work together inside the same pod. In most cases, a pod contains only one container, but Kubernetes manages it through the pod. If the application crashes, Kubernetes can automatically restart the pod to keep the application running. The next question is, what is a node? A node in Kubernetes is a machine where Kubernetes runs and manages pods. A node can be either a physical server or a virtual machine, and its job is to provide the CPU, memory, and storage needed for running the applications. In simple words, if a pod is like a passenger, then the node is like the vehicle that carries and runs that passenger. For example, in an e-commerce application, Kubernetes may run multiple pods such as login service, payment service, and product service. These pods are distributed across different nodes. If one node fails, Kubernetes can move the pods to another healthy node, so the application continues working without any downtime. Coming to the next question, what is a cluster? A cluster in Kubernetes is a group of nodes working together to run and manage containerized applications. Instead of relying on a single machine, Kubernetes combines multiple nodes into one cluster so applications can run reliably, scale easily, and handle the failures efficiently. A cluster usually contains a control plane, which manages the system, and multiple worker nodes which run the pods. For example, in a banking application, one cluster may contain several nodes running different services like login, transactions, notifications, and customer support. If the traffic suddenly increases, Kubernetes can distribute the workload across the clusters. If one node crashes, the cluster automatically shifts the application pods to another node to keep the system running smoothly without any downtime. The next question is, what is the control plane? The control plane in Kubernetes is the brain of the Kubernetes cluster. It is responsible for managing and controlling the entire cluster. The control plane decides where the applications should run, monitors the health of the cluster, schedules the pods on the nodes, and makes sure the desired state of the system is maintained. For example, suppose an e-commerce application needs 5 pods to handle the customer traffic. The control plane checks the available nodes and decides where those pods should run. If one pod crashes, the control plane detects the issue and automatically creates a new pod to replace it. In simple words, worker nodes do the actual work while the control plane manages and coordinates everything behind the scenes. The next question is, what is kubeAPI server? Now, this is the main entry point of the Kubernetes control plane. It acts like a communication hub between the users, the tools, and the Kubernetes cluster. Whenever someone gives a command to the Kubernetes, such as creating a pod, scaling an application, or checking the cluster status, the request first goes to the kubeAPI server. It then validates the request and sends it to the appropriate Kubernetes components for processing. For example, if a developer runs a command to create 3 pods for a web application, the request is sent to the kubeAPI server first. Now this will receive the request, check if it is valid, stores the information, and tells the Kubernetes to create those pods on suitable nodes. In simple words, the kubeAPI server works like a receptionist or the central manager that receives all the requests and then coordinates the communication inside the cluster. The next question is, what is etcd? etcd in Kubernetes is a distributed key value database that stores all the important information and configuration data of the Kubernetes cluster. It keeps the details such as pod information, node details, configurations, secrets, and the current state of the cluster. Kubernetes uses etcd as its main data store so that the cluster always knows what is running and what should be running. For example, suppose a company has deployed 10 pods for an online shopping application. Now, information about all these 10 pods, like their status, location, configuration, is stored in the etcd. If one pod crashes, Kubernetes checks the data in the etcd and understands that the pod should still exist. So automatically it creates a new one. In simple words, etcd acts like a memory or a database of the Kubernetes that stores the entire cluster's information safely. Coming to the next question, what is kubeScheduler? The kubeScheduler in Kubernetes is the component responsible for deciding on which node a pod should run. Whenever a new pod is created, the scheduler checks all the available nodes and selects the most suitable one based on the factors like CPU, memory, resource availability, and workload. Its main goal is to distribute the applications efficiently across the cluster. So there are clusters, then they have the nodes, then they have the pods. So the kubeScheduler, what it does is like it is responsible for deciding which node on which node the pod should run. For example, suppose a company creates a new payment service pod for an e-commerce application. The kubeScheduler checks which node has enough resources and is less busy, then assigns the pod to that node. If one node is overloaded, the scheduler avoids placing new pods there. In simple terms, the kubeScheduler works like a smart traffic controller that decides the best place to run the applications inside the Kubernetes cluster. So this was the part 1 of Kubernetes interview questions, and we have covered only the basics. In the next few videos, I'll be covering some more important Kubernetes interview questions. So don't forget to like, subscribe, and turn on the notification bell so that you don't miss the next parts. See you in the next video. Thank you.